an application question of trigonometry. The number of insects in a certain area varies according to the rule. N of t equal to 800 minus 400 cos pi t over 6, where n is the number of insects after a time t months after the 1st of January, say 2015. State the amplitude period of the function n, find the maximum and the minimum population of insects, find n of 20, and over the first 24 months, find the fraction of the time when the number of insects is greater than n of 20. Alright, a little bit of things perhaps we need to know here is some things about trigonometry. So the graphs of a sine nx plus or minus alpha or cos, both of them have got an amplitude of a. Now the amplitude is always positive here, even if it's a negative, that's just a reflection in the x-axis. The period is 2 pi on n. Be careful then, sometimes exam questions ask for the period of tan graphs. Tan graphs have got a period of pi on n, not 2 pi on n. And also, tan graphs do not have an amplitude. We have a horizontal translation or a to the left or the right, depending if alpha is positive or negative. Alright, now even though this question is defined for n's and t's, when we graph this on the Nspire CAS calculator, we have to use f1 of x and x's, not t's. So we know we're talking about t's and x's, although we're talking about x's. So what's the n here? The n is the value next to the t. So the n is pi over 6. So if the n is pi over 6, on a calculator page, 2 pi divided by pi over 6, so 2 pi, if I want the pi, I get it from this button here, 2 pi divided by pi over 6, that's equal to 12. So if we think back to the question is talking about 24 months in the last part of the question. So 24 months is in fact 2 cycles here. So when I graph this, we would have got some general solutions and things like that appearing. So what I've done is I've defined the function given that x is between 0 and 24. So that means that when I sketch the graph, I'm only going to see it between 0 and 24. So what was the first part of this question again? Find the maximum and the minimum. Well, the amplitude is 400, not negative 400. Okay, now, the maximum value is 800 minus 400, or 800 plus 400, which is going to be, what, 1200 to 400. So if I want to sketch this graph now, I'll open up a new graphs page, and pressing up arrow, I'll see the graph. Now, this is where a lot of students start panicking. We don't see a graph here. We should be seeing a graph. The reason we're not seeing a graph is because my window settings are not quite right. So, pressing menu, window, window settings. What should I be putting for my x minimum? I don't want to see any negative values, but I do want to see the y-axis. So I'll leave that as minus 10. I want to see at least 2 cycles, which was 24. So I'll say I need to go up to at least 30 there. My x scale, well, we'll say 6. My y minimum, well, we'll say minus 200. And my y maximum, well, the range was 800 plus 400, so that's 1200. We want to see a little bit higher, so we'll say 1300. And my scales, well, we don't want to see lots and lots of tick marks, so we'll say 200 there. And now we see the graph quite nicely there. So now all of these graphs have the same sort of basic shape if we set our window settings correctly. So the maximum value is 1200 and the minimum value is 400 here. Let's look how we can actually think about doing this question, the last part of this question. Over the first 24 months, find the fraction of the time when the number of insects is greater than n of 20. Well, what's n of 20? We haven't found that in part 3. We can do that on the calculator page as well. So on the calculator page, n of 20 just means we have to evaluate the function f1 at 20. So that's 1,000. Okay, so come back to the graphs page and let's type in 1,000 there, or I could type in f1 of 20. It doesn't matter because it's the same value. And now we want to solve when they're equal. Let's move that out of the way. So I want to find the fraction of the time for when they're equal. So if we go Menu, Analyze Graph, find the point of intersection this time. Again, move your cursor to the left of the point of intersection. That's 4 and 1,000. Let's do that again. Menu, Analyze Graph, Intersection. So that's 8. So you would think that if we did that again for the next one, okay, we'll just repeat it one last time. Menu, Analyze Graph, Intersection, and move it out the way. So 1E3 is 1,000. So between 4 to 8 and 16 to 20, remembering the period was 12, so from 4 plus 12 gives me 16. The fraction of the time for which this function is greater than 1,000 is from 4 to 8, which is 8, and another 16 to 20 is another 4. So the total time overall will give me 8 out of 24, or 1/3 of the time. So summarising the whole answer to this question, the amplitude is 400, the period is 12, the maximum value is 1,200, the minimum value is 400, and from 4 to 8 and 16 to 20, we have a total of 8 in 24, so the fraction of the time is 1/3 of the time. All right, now that's sort of a typical sort of exam sort of question in modelling a trigonometry application type question, which we can do very neatly on our CAS calculator. We solved it graphically, but we could also have solved it on the calculator page. So if I wanted to go Menu, Algebra Solve, solve f1 of x equal to 1,000 for x, comma x. So that gave me the 4 answers as well, 4, 8, 16 and 20. So we did it on the graphs page and also on the calculator page. But I think the calculator page shows us the fraction of the time a bit more clearly. Also here, it's important to realise that I've restricted the domain of this question, otherwise we might get some general solutions, and that way we're ensuring that the graph is only showing 2 cycles, because one cycle is 12, so from 0 to 24 was 2 cycles.